Good afternoon, everyone. Welcome to CITRIS and the Bonato Institute. We're really delighted to have you here this afternoon. My name is Camille Crittenden. I'm Executive Director, and we want to welcome you all here in person, as well as those who might be watching live online. The research exchange talks that happen here every Wednesday afternoon are also recorded and made available afterward on our YouTube channel, so feel free to check out previous talks as well, but we're really glad to have you here in person. So I'm really delighted to present Dr. Lisa Yo, who comes from our fellow CITRIS campus at UC Merced. She's going to be talking about cybersecurity today, which is great, as October is Cybersecurity Awareness Month. She'll tell you a lot more about that, but we're really pleased to have her here. We'll have an opportunity for Q&A after she talks, so we ask that you hold your questions until the end. We'll have people going with microphones at the end, so you'll have an opportunity to chat with her. So Professor Yo is an assistant professor in the Ernest and Giulio Gallo Management Program at UC Merced in the School of Engineering. She helps organizations understand how to safely govern the data and information they need to compete. By focusing on people and processes, Yo believes that organizations can design and build information systems that make it easy to protect privacy and prevent security breaches without requiring extensive investments in security layers after the fact. So we'll hear more from her about that. She has degrees in applied math from the University of Waterloo and MBA and PhD from the University of Alberta. So please join me in welcoming our speaker, Professor Lisa Yo.
Thank you. Thank you, everyone. It's a pleasure to be here. On this lovely day and not be in Alberta, that's for sure. So coming to California was a very good choice overall. A little bit about me. So yes, I do have a degree in mathematics. That is my undergraduate. I'm an applied mathematician as my original plan in life. I moved out to Alberta after I got my degree, and I worked in what I would essentially say and identify as a systems administrator. So I was a sysadmin for small companies, for the province at one point in time. And I go back far enough that this was pre-internet when I first started working. And I think about my job and my role as a sysadmin as being about keeping computers up and running and working. What I didn't think about at the time, but I now sort of realize, is that was very much a computer security, cybersecurity type job, dealing with the availability of the resources. So if anyone knows the cybersecurity people talk about this triad of confidentiality, integrity, and availability. And I was really focused on a little bit of integrity, a lot of availability, and making sure the resources were available for the businesses to work. Now, just because of my role, I moved into what we think of as more traditional cybersecurity. I eventually worked for the province of Alberta, and I had to secure, we had our systems that connected to the internet. I became the firewall administrator. And when I became the firewall administrator, I became the person who made decisions about what we could and could not do because it was too risky. I was a techie, I ran computers, and so I knew all the technical risks. Oh my goodness, people will invade our computers and steal our data. And I had all of that same sort of fear instilled in me about what could be done. And if someone came to me and said something, I'm like, no, that's too risky, I shall not do that. But at some point in time, a piece of me said, this seems a little wrong. I don't actually understand the business well enough to be making decisions about what you need to do to get the job done and what is risky. And so I started to think about, this is how I ended up in the MBA. I thought, I need to actually talk business language so I can help business decision makers make decisions about what's right, and then figure out the security side to enable them to do what they needed to do and not just say no all the time. They trusted me a lot. It was kind of weird. And so that's how I started to sort of change the way I thought about security and how I did my job, and how I would really like decision makers to have an easy time baking in secure, safe, protective ways to do the work they need to do right from the beginning, so we're not just layering on after the fact. So this is sort of how I morphed into things. Somebody talked me into a PhD somewhere in there, and I thought it was a great idea, and I did it. And I actually did it in operations management and information systems. So I'm an OM-focused person. I use operations tools. So it's about like maximizing efficiency. I do some game theory stuff about trying to find like the optimal response to some sort of activity. And that's really the tools that I use, but I always think of it in terms of how do I enable business, how do I help decision makers think about what they are doing when they're making choices, when they're designing something. And I personally care a lot about privacy protection and the cybersecurity. I think probably a couple of years doing some consulting with public libraries really made an impact on how I think about privacy and how it's done. So this has really been some neat stuff. So today I want to talk a little bit about sort of broadly what we're doing with technology and some work that I'm doing, one piece of some of my work that I'm doing that looks at how maybe we can see how innovation and security sort of interact with each other and what's going on, how data breaches really can impact what we do as we design new systems. And this has come out of a little bit looking at how we build so much technology and so much data collection into so many of our new tech tools and our new tech toys. So this idea that in a business sense, innovation is important, it creates value. We invent something, the innovation then enables us to sort of package it and somehow disseminate that. And we have this dissemination factor. We are starting to put, for example, as an innovation, what we label artificial intelligence, what computer scientists might say it's machine learning and it's sort of data collection and data mining. But these abilities to use sensors and data collection to see the world around us, to make decisions, to enable products to be more useful. And what frightens me is the data collection side of things, what we do with that data and how that could be abused. How can we break these systems? I had an opportunity to talk to third grade students yesterday. We talked about how can we break some of the image recognition going on and what that means to us in our world around us. So if I broke or I lied to that car up there that is trying to sense where it is in the environment, if I have some way of lying to it about what's around, could I get it to drive into another vehicle and not keep me in the right lane? Could I use what I know about our in-home, smart home systems to abuse that? And I could do something crazy by turning all the speakers on. We'd have some horror movie going on. We've probably seen this in horror movies. They like to make all the machines do stuff. So we can do these sorts of things. Oops, sorry. This is me trying to scroll the wrong thing. And so this is kind of where I'm coming at when I'm talking about this. This is one of the things that we look at. Because we are collecting so much data, what are we doing with it? And so the good news, the good things we can do with this, there are some researchers, it's Ostrom and Schultz who've done some work, who've suggested if we have these really great sensor networks, if we can get real-time data about where cars are going, if we can have self-driving cars with real-time data and sensors, we can use things like real-time toll pricing to redirect vehicles in an environment so there's less traffic congestion, which could be good for cities because you don't have to build as many big roads. Could be bad for neighborhoods because now you have cars being routed through them that you wouldn't normally. But we can do all of this stuff and it can be really wonderful and useful to people who have to commute. But, and in terms of sensors, we don't even have to load sensors in the cars. Every one of us is wandering around with a sensor in our pocket. So we could just use the phones to do some of this and for this real-time tracking. The but is that what if you are trying to hide for some reason? What if you are a journalist in a part of the world where your life could be at risk? What if you're an activist or a dissident? Then now I know exactly where you are at all times because I have an entire road infrastructure system that's designed to try and route you around. If I'm trying to find you or stalk you, I can do that very easily. Depending on the extent to which this is government controlled, could I actually route you to a place where I could then just intercept you? So there are some real problems with doing this. There's some great societal problems we could solve, but we introduce new ones, and I'm interested in the introducing new ones. The auto insurance industry has figured out, and they've been doing this for a while, they've been figuring out if they have sensors in the vehicles, and you can buy policies where they put a sensor in the vehicle and it monitors your driving. And that means you can create insurance instruments that are only active while you're driving. So I don't have to pay for insurance by the month. I can pay for insurance by the mile I drive, which is good. It can monitor how I drive. So if I'm a really safe driver who never goes on crazy highways with really big trucks and is less likely to be a risk, I should theoretically get lower premiums. But again, we have the same problem. If we have this real-time driving data, we have the same problem of tracking individuals and being able to know where they are and what they're doing. And where there are vulnerable populations, this could be incredibly risky. Who gets this data? What do they do with it? And who actually decides what is risky driving and what isn't risky driving under certain circumstances? And this is a fun one. Has anyone seen these? I always do this with my students. These are eye beacons. And so these are typically used, so this little blue thing is one of the beacons, and you put it in a physical location. You can put it around campus. Stores, retail stores will put these around. There have been some sort of big sports arenas that make use of these facilities. And it can track, it uses Bluetooth to connect to an app on your phone, which you may or may not know is enabled for this. This is the latest iOS update, is starting to tell you that you have all these apps that want to use Bluetooth that you'd never thought about. Some of that was because it was enabling some of this type of background tracking. The good news from a retailer's perspective, and retailers would argue it's good for you too, is when you are in a place, we can offer you specialized deals. You happen to be standing right beside this, this shelf full of artifacts. This looks like art here. I can give you a deal on this art today. Here's a coupon, because you're here and you probably want to buy right now. I can use it in stadiums to track where the crowd flows are. And that can help me maybe figure out that I need to send more people to help deal with the crowd flow. Maybe there's too many people lining up for hot dogs at this particular vendor. Can I find a way to move them to a different part of the stadium? So they are useful, at least from a business perspective. But they continue to enable us to track people. Some of the other, I'm talking mostly about tracking, but we have our home environments where I have a slide for that. Let's see. So localized offers crowd management. This has been in the news fairly recently. These are all the various, I grabbed one from each so that I could be an equal opportunity concerned person. Google's home device, Alexa, Amazon is Alexa, Apple's Siri and Cortana, so whatever Microsoft is using, and Skype is also in there with Microsoft's. And essentially the argument that when we are talking around these devices, people are listening. There are actual people somewhere listening to us. It's not just the device listening to us to learn language better. It is human beings, and what's happening with that data. And this has been a concern. And my research, this is actually really nice for my research because all of the companies are reacting to it, and they're kind of reacting to it in a way that I would suggest would happen. My research suggests should happen. So this is kind of really neat. What is also happening, there's a company, I always have to look up their name because I forget it, and I don't have it on this slide. There's a company that's building employee IDs, you know the ID cards that you basically badge into everything. They've built one that has Bluetooth, RFID, and an audio recording. So they're recording all the data, who you're talking with, so who you're near, because the badges are have proximity sensors, can track who I'm near. They can track where I am in the building. They record the conversations and use them. And this is changing the nature of work. These are, they argue that privacy is important and we are somehow protecting the privacy of the people saying things. But you got to imagine that this makes you a little bit nervous of, if I criticize my boss, is that going to come back to haunt me? Because I'm always on listening. So my argument here, we create this technology, but we don't think about security and privacy as some of the core features. Those are things that happen later on, or we just never think that there's going to be a problem. I had a lovely conversation with a colleague of mine, and we were talking about this car driving issue, and they could be tracked. He's like, oh, what do I care if somebody knows that I drive this route? I'm like, oh, sweetie, that's your privilege showing. There are people who maybe are in a domestic violence situation who care very much about a stalker or a violent ex-partner being able to know where they are. It's a very different world. And so a lot of what we design comes from this privileged view of people are not going to abuse this. Even though history shows us that people abuse all the technology we can come up with, we still build that way. And so until we can figure out how to change this, and it's not to say that there aren't engineers and scientists and computer scientists and developers who don't know how to do better. Sometimes the people with the money-based decision makers, don't give them the time to do better and don't make that a priority. And so that's my concern. Yeah, we still need research on how to do better. Like, we don't know how to solve all of the problems. When we build new, we don't sometimes anticipate some of the things we create. But at the same time, we need to make sure that the people who are designing it have the support that they need to do the work. And that's been I don't know, this is some sort of core piece to me that we got to convince to push this all back. One of the other reasons this hasn't happened, now this is an older piece of research, and we have to expand software into the software hardware realm, everything's connected, but the social costs associated with failures of these technologies are not borne by the creators, are not borne by the people who sell this to us. And so, if they are not paying the cost of the failures, they have no reason to think about bearing the cost of making it better. Right? If I'm a business person, I'm completely and economically rational, I just want to make a lot of money, and this is just going to cost me money to make it more secure, and there's no penalty to me. There's no significant penalty to me to fail. You read in the news, oh, there's been this breach. Oh, there's maybe a fine, a federal fine. Oh, they're going to have to pay for security monitoring. I would provide as evidence that this hasn't improved simply the Experian breach, where we have no control over the fact that they collect our data. This is one of the 3 credit reporting agencies. They lost like 140 million records. And yeah, they have this big fine, but it's nothing. They can't afford to pay $125 to each person who has been harmed. In fact, they can't afford to pay that much. The fine won't cover that for the number of people who said, I want the money instead of I want the credit reporting monitoring. And you got to think, well, why would I let the company that lost my data monitor my credit for fraud, do the ID theft monitoring? And so a lot of people chose the $125, and yet the fines, sure, it's in millions of dollars, but there's nothing to this company, and it doesn't even cover the losses of the individuals. So this is even now, right? That's 11 years ago, but even now we are not doing better about making the companies who are in a position to make these decisions. I can't decide not to share my data with Experian, with TransUnion. I don't get that choice. So we need them to make these decisions for us. So what do we have? What are the levers we have that can change this focus? How do we apply them? These are some big questions that I have. Understanding that I come from a game theory, management science background, a little bit economics thrown in, you can expect I'm going to go for some sort of fully rational approach, knowing that humans aren't fully rational. But we'll see how this goes. This is what I think we need to do. We need to actually start thinking about security and privacy as a core feature in everything we create. There's a practitioner, she works in industry, and she used to work, she's actually just left Microsoft, and she's written some papers or some posts about, it's like called Pushing Left Like a Boss. And so you think, okay, is this person political? It's like, no. For those in computer science or those in systems development, there is this sort of historic classical model for how you do systems development life cycle, and it says you start, and I will probably be missing some steps, so anyone knows this really well, I always forget, but the classic approach, so let me think about it from your left, is you do your analysis, your planning and analysis, you do your design, you start to do your development. If you're rapid, any of the people who are doing rapid stuff, there's like some loops in here, but let's just go classic, slow, linear. We do our development, we do our testing, we do some sort of implementation, and we roll it out. And so the idea is that instead of discovering that there are problems somewhere in the testing, implementation, maintenance phase, at the end, at the far right, we push this up to the left side, and we say right at the beginning when we are designing the system, a key requirement, if I need to collect this data so that I can track where a vehicle goes, so that I can help route better in the city, okay, I need that data, but I need to make sure that my citizens are not harmed. So how do I protect that data? What do I really need from that data that makes sure that at the very beginning stages, I start to figure out in my blueprints what I'm going to need to make that happen? It doesn't mean we aren't going to get to the end and find something. If we're reliant on other software at some point in time in the future, we're going to find some sort of disconnect where there's a problem, but the idea is let's push it to the beginning. I was also, in prepping for this, I watched Yuta Williams' talk from a couple of weeks ago, and she also mentioned, right, I want to move this as far into early development stages as possible, because that's where that's really where it's the cheapest to make these changes. And it should affect everything. So I want to push it up there. Needless to say, I really loved her talk because I think like her, apparently. So what am I talking about and what I'm doing right now? My basic premise right now is that innovation, I believe in innovation, I like innovation. Innovation is good. I'm a big tech fan. Doesn't mean I use everything that comes out, but I'm really But we have innovation. Businesses innovate because this is where they're going to get their growth. They're going to continue to make money. They're going to make their shareholders happy. They might solve societal problems for those who are less sort of necessarily profit focused, but problem solving focused. So innovation is good, but when we innovate, and in a tech environment, I'm going to be talking about innovating as adding features. So we have something and we're going to add some sort of features. It creates complexity. So how these features interact, how we do development usually means we have a bunch of teams working on things and we have to piece them together. And so that adds complexity. And when we increase complexity in technology products, we increase the vulnerability. We essentially expand an attack surface. We have more opportunities to try and attack something, which means an attacker is more likely to find something they can leverage to solve what their problem is, which is to gain access in some way. So this is my basic philosophy. As an example, let's talk about this. So Android, for example, Android versus iOS. Android platform is very customizable. So you will find that the OEMs, the original equipment manufacturers, so Samsung, whoever else makes Android handsets, Nokia. You can tell I'm not an Android user, right? I'm like, I don't know who makes these handsets. But essentially, whoever makes the handset customizes the current version of Android operating system that's out. And then whoever is selling you that phone, whoever your telco provider is, often also has some additional tweaks and customizations that they do. And so what can happen is you no longer have this original version of the Android platform, and when the next release of Android comes out, it takes a long time to filter through. If anyone's ever done any corporate patch management, you know that patch management is hard in a corporate environment because you have to make sure you didn't break anything on the way down, and you have to customize it all. And so you have this problem. There is actually research from 2013, there were some researchers, Wu et al., who really looked at this and said, they discovered a few things, like I believe it's like close to 85% of the pre-installed apps on Android platform phones are overprivileged, which means they have more access to do things in the operating system than they need to do their jobs. So that's one big problem, right? It violates a general security principle of sort of least privilege. You should be allowed to do only what you need to get your job done. You shouldn't have extra stuff. That's why I'm not allowed to like go in and change the pay scales for myself, right? Like, we would all just give ourselves all the money. So those are the sorts of things that you do. So that was one part. And they also found that, and because this is kind of a big range, the majority of vulnerabilities are actually coming from these tweaked, modified systems. It's like 65 to 85% of the flaws in these systems are from these tailored applications. And that actually means, it's actually unfortunate, normally we expect security to get better as the models get newer, because we learn. It actually turns out that a lot of the Android platforms, the newer models, are less secure than the older ones because of this ballooning complexity. And so we thought, okay, what do we think about this? And we went out, and this is data from the NIST National Vulnerability Database, and we had a student that's now 2 years old, so we'd have to do this again. A student go out and look, and they essentially said, what are how many apps are in each of the stores, the Android and the iOS stores? And it is true, because Android is a more open platform, that there are more apps developed. This is nice, that's innovation, that's good. But the number of vulnerabilities is much higher. in the Android apps based on the reported National Vulnerability Database. And so these are some issues. And we would argue then that these lockdown platforms, and I'm not, lest you wonder, I'm like this Apple super fan. I'm not. I'm a Windows user. I have an iPhone. I don't believe Apple is 100% secure. But in this case, their historic approach of locking down and simplifying their ecosystem has assisted to some extent in the types of vulnerabilities. Now, these are vulnerabilities where things can be broken. These aren't the same as, oh yeah, we allowed this application to use Bluetooth and so it can track you, right? Those were sort of by design issues. These were identified vulnerabilities. So we have some evidence for our basic thinking that security and choices about security have impacts on choices about our ability to innovate, and vice versa. We have some credible research that says software companies rush things to market. You want to make money off this. You don't want to keep it in development forever. You've got to start making money. It's not surprising from a business perspective to see this happen. And so now we're getting into sort of a project that I'm working on. It's there's a sort of this theme of work that I go through. But here's the basic idea with this one. If features open up vulnerabilities, how do we find this balance between we have enough features to sell well, and yet we have it secure enough to make people comfortable using it? And is that sort of secure enough to make people comfortable? We could argue, is that socially optimal? So that might be good enough for us consumers, but is it really good enough for everyone? And so we say, as I look at this and I model, I'm like, with more features, we get more demand. People want new stuff. They want to be able to do stuff. You might be one of those people like me driving an old car that doesn't want it to be completely internet accessible. That's fine. We're weirdos. Most people are liking the new self-driving things, and that's going to require some internet access. So the problem, though, features increase the attack surface, so they increase the vulnerabilities that can exist. This leads to a higher likelihood of there being some sort of security breach, data breach. It's not a one-to-one mapping, right? More vulnerabilities, you still got to find them, you still got to be successful. And that security incidents decrease or suppress demand. That's the really basic process for a particular firm. So if I'm a firm trying to make decisions, I want more features, but I got to be careful because I got to balance at some point in time. I'm going to do something so creepy nobody wants to use my product. I'm going to be building a self-driving car that accidentally runs over people. That seems like a bad idea. It's going to suppress demand. But what we also are looking at when I do this is we say we generate an externality, and this isn't the one that we think of in terms of it becomes a problem for all of us if there's a failure. We actually say it affects the competitor. And you're like, okay, that makes sense, right? If the Tesla self-driving car is not doing a good job, Tesla is probably a bad example because they're such a strong, dominant player in the industry, but let's pretend that they're just equal. If they have a self-driving car problem, then what could happen is that one of the other self-driving cars could get demand. So I was going to buy a Tesla, but now I'll buy whatever GM's doing. Or Toyota's probably doing. And so this is a substitute. We classically think of this. If my iPhone, if I feel that the iPhone is not safe enough, maybe I will switch and buy an Android because I think it's more secure, or I can do something about it. But we also have seen on occasions where you actually suppress demand for both. Myself, if I have a breach in my product, that's going to suppress demand for competitors. And this is where this idea of these smart home devices, the Alexas of the world, when Alexa is found to be listening to you, you're like, I think all of them might be listening to me, so I don't want to buy any of these. That's my home. I'm currently smart homeless, even though I love some of the things it can do. And so we think about it this way, and then as a result, what does all of this do to my demand? So you actually have to think about, I've never been able to figure out how to draw this properly. The same situation is happening for the competitor, right? They have these features, they're figuring out their demand, they have vulnerabilities, that creates externalities that affect me. And so there's this sort of two players, and we have this balance. So how does all of this stuff, as a result of security incidents, how does that influence my decisions on investing in features? Or how should it? This is the basic premise. A few assumptions because this is academic work. So there are assumptions. One, we've seen some of it, right? More features increases vulnerability. Increased vulnerability increases the likelihood of a security breach. That's all the first one says. Choosing, so I'm going to let my developers, I'm going to have two developers, two companies building their products, and they can choose between being a low or a high security provider. Now, low is just baseline what we're doing now, and high is, hey, we're going to take some extra care. So low is relative. It doesn't mean no. So we have a low and a high. If you become a high security developer, that's going to have the advantage of reducing the likelihood that a breach can occur. It's also going to theoretically cost you more in some way. And you can model that as it takes longer to get the product to market, or it actually costs a little bit more to create each feature, however you want to deal with that. That when a firm has a breach, we assume that there will be some suppression of demand, that will have a negative impact on demand. If only for a short period of time, we don't worry about that. We just know that it's going to reduce demand. And then this flip side, if I have a breach, it's going to do something to my competitor, it could go up or down. If my competitor has a breach, it could do something, I could go up or down. And then prices are fixed. So I don't want to deal with pricing, so you take a price. That means that everything we do is margin, affects the margin. I want to sell more because then I'll make more money, because even though my margin is smaller, I've sold more product. Some of the economists argue about my price is fixed thing, but I'm like, it's hard enough now to solve. And so this actually leads me into three cases. So I have an opportunity here. My firms are identical. I'm basically making this as simple as I possibly can. And I'm saying, so I have these cases. I have both firms choose to be low security providers. I have the case, that should be this one. I have the case where one firm is low and one firm is high. And because these firms are identical, these are both the same, right? It's just symmetric. It's a mirror image. And then I have the choice where both firms are high. And so what I actually do is I set all the math. I have no math in these slides. I wasn't sure how people felt about it, so I thought I'd take it out. I like it out. So what I do is I take each of these cases and I set up the model and I say, okay, if they're low, here's what the answer is. If there's a low high, here's what the answers are. If they are high, here's what the answers are. And the answers, what are the answers, are how much money should I invest in features? And I say that translates to the number of features that I create. And how much money will I make at that point? And the idea is I find an equilibrium where the two firms have hit a point. I don't know who I'm explaining this to, so we're going simple. We'll hit a point where there's no point in them moving off, right? They've basically maximized because there's this connection of the security breaches. What my competitor does affects what I do, and what I do affects them. And so we will just sort of like move to this key equilibrium point, and I can solve that for each of these three cases. Calculus is your friend. Mathematica is really your friend. Simulation programs too. And basically what I find is, let's start off with, let's say security costs nothing. Let's just pretend that. And if that happens, then what we find is, regardless of what's going on, what we find is that the most features, so pluses are the number, some number or amount that I invest in features, pluses, the most features are always developed in the low situation. The fewest are always developed when I'm a high provider. So as you choose to be a high security provider, the number of features that you should develop go down. You should do less. Okay. And in this case, when security is free, when you choose to be a high security provider, you make more money. Fewer features, more money, because you spend less time at that suppressed demand state. And this is across the board. This doesn't matter whether or not I switch, like people switch and go to the competitor as a result of a breach, or if the entire market gets suppressed. We make more money. And you'll see, yes, it is really true. So when I move, let's take this row here. So firm one is low and high. So in this first one, when we move from the low state where firm one is low, firm two is low, and we move down to firm one is high, but firm two is low, it is really true. That's where firm one can make the most money. They develop the fewest, well, they don't develop the fewest features, but they develop fewer features and they can make the most money. What's neat about that is from a pure game theory perspective, when you go the other way, For 2, just playing on its own would say, hey, if I go high, I make the most money. I don't even care what the other people do because I always make more money when I go high, so I'm going high. For 1's going to say I always make more money when I go high, so I'm going to go high. And so this will actually always land in the high state, which you can't see here because I couldn't figure out how to do fractions of dollar signs to make it obvious, is that the profit, so the total profit across both firms is in fact highest in the high state. So even though it looks like the same 4 dollar signs are available, there's actually more dollar signs total in the high security. It is not true, however, that like what you get in high as the high is not more than what you get in high-low as the high. But that doesn't matter because you're always going to go, hey, I'm making more money. You're going to make your own individually rational decision, and you're going to land in this corner, which is still better for everyone. Fewer features, fewer breaches, more money. Better for everyone who's playing, and we haven't considered what we as consumers think yet, other than the fact that we won't punish them for being breached because they won't be breached as much. Now, the problem. Nobody believes that security is free. So I have a method that enables me to say, okay, let's just slowly raise how much it costs for security. And as soon as I start introducing cost, we pretty much get the case where everyone will be a low security provider and they'll just throw lots of features at you. That is almost always the case. I say almost. There's an exception. So this is this whole part about my margin goes down when I start spending money on security, so why do it? I can just sell a whole bunch of stuff, and the fact that I don't have to pay for the consequences in the end mean that I don't have to worry about it. There is this tiny, tiny little window of opportunity, and right now I've been doing some simulations. Right now it's about like 1%. If security costs 1% or less, it has an increase of 1% in the cost. I can get situations where you can actually make more money if you cooperate and both choose high. Unfortunately, like unlike the first one where there's sort of this natural tendency that you'd land in high because your individually rational choice is to go high, you always make more money. It's not true here. You make less money if you are high in a high-low than you do in a low-low. So you would never choose that on your own. And you have to find some way to cooperate. For those who do game theory, this is a classic prisoner's dilemma. You need to cooperate. You need to find some sort of coordination mechanism that encourages you to work together. It's typically in situations where, or this only occurs in situations where what we call a lose-lose. So if you have a breach, some of my customers leave. If I have a breach, some of your customers leave. This is kind of classic. What it's doing is it's suppressing the market. So this is why I say what's going on with the whole Siri, Cortana, Alexa, hey, oh yeah, we messed up, and that actually suppressed the market. And now if they start figuring out a way to cooperate and make us trust them somehow, they'll open up the market, and this is better for them. So this is a place where cooperation should matter. So we could do this. But as I said, it's tiny, can't be very expensive, it's really tough. So one of the things that I haven't really fully explored yet is the piece where policy plays a role. So how much do I fine a company? How much do I charge them back for the fact that their security breach created these social ills in some way? And figuring out how to do those policy levers is the next sort of stage to look at this, because that is a policy question. Because this isn't gonna, your industry, you're making money. You don't want to voluntarily suggest that you would somehow take on additional costs for no good reason. So that is a piece that still needs to be worked on. So there's an opportunity to cooperate. And sometimes we just sort of look around for these. And I would argue, so I am old enough, as I said, I started my work career before internet. And so for those of us who remember this, I don't know, I think a few of you are probably in my age range. In the early days of e-commerce, people were afraid to shop online. There's two major problems that could happen. One, I could order it and it never comes to me, so there's sort of this whole, do I trust that this company is going to send me what I want? But the other one was, I'm going to put my credit card number out there and people are going to steal it and start charging things. And while there were some problems with that fear, it existed. And so what we saw was that companies came together to develop standards, and there were some secure HTTPS, which we see everywhere now. There were some secure standards, but they came together to really work on industry standards and industry-based communication to everyone to convince us that if I use my credit card online, it's not going to get stolen. It's no more risky than handing it to the gas station attendant who wanders off and runs it through a machine. And that really enabled the industry to expand, and we live in this world now where we can't imagine not shopping online. And so this is kind of this place where the cooperation can work, and this worked without interference, real interference from a policymaker. It's not to say that policymakers didn't have to come in later to control things, but this is a good start. A little worried about time right now. So where do we go from here? Policy around what can we do? How do we incorporate or reinstill this fact that this data collection has societal issues around it, that there are differential harms that can come depending on the communities that we're working with. That's leading me to look into things like where these differential harms can come. How do we intervene in online abuse, for example? How do we deal with some of that? I'm just getting started in there, so I have a lot of reading and research and communication to go on that still needs to go there. We definitely need the policymakers, because the decision makers aren't going to get there on their own. I would like, at some point in time, to have convinced people who make technology and to provide them with the tools to create technologies that are actually really easy for an end user, not necessarily a technically savvy computer science, knows everything about how computers work user, but an average everyday consumer end user to be able to choose that product and configure it quickly and easily and safely, meeting their own personal privacy protecting needs. In other words, how can I make it really easy to use this tool securely? And I come to the language of affordances. So what's an affordance? I look at these doors here, and they have these lovely push bars. So when you try and go out these doors, you know to push them. There is no other alternative. But I think we can all think of places where we see doors, and they have this lovely handle for me to grab, and you grab it, and it does not pull. That is a bad design, right? Because every time, if you use that door every single day, you will eventually remember that it is a push in this direction and a pull in that direction, but it's got this pretty little handle that always says pull. That's a better designed door. That's a designed affordance. I want to do that for security. I don't know how. I'm working on it. I'd like to find more people who want to work on things like this with me, because I think we need to go there. So to that, I say thank you for your time. We'll have time for questions, but I have one more slide. I had a student giving me a pep talk, said, oh, you know what, if nothing else, make sure you throw in a Canada meme. So here's my Canada. I used to start classes with these. I've been in Calgary, Alberta for about a month, working with some colleagues there. And while this is an old from the internet, I don't actually know when this was taken kind of thing, this was taken after our first snowfall, which happened the last weekend in September. I took that. So yeah, I'm really happy to be in California. Thank you, people. Hi. There's a mic here. And since they're recording, we should do that.
Awesome. Sorry for a slightly long question, but when we see transaction platforms like stock exchanges or pricing platforms, etc., they are very well regulated and the security breaches there are very, very well controlled. But when we talk about data storage platforms like Amazon storing customer data or Facebook storing customer data, they are not at all regulated or moderated. Is that something that the government needs to do, or is that something that corporates need to get together and do?
I think we're going to have to yes, government is going to have to get involved in regulation of this. It is really interesting that, so far as I can tell, when we look at, I think about Experian and some of the big data collection spaces where we have less control. I can make a choice not to shop on Amazon. Theoretically, I can make that choice. But I can't make a choice about where my credit data goes, and there's a lot of places where even open source government data is being collected in these places. And they say I can go in and change and dispute stuff, but I can't stop them from doing it. And so, yes, I do believe there's room for more regulation, and I hate to say that, businesses hate regulation, but I think in the interest of public good, there's going to have to be more intervention from public policy. I don't know what the right answer is, though, in terms of what that policy needs to look like.
Hi, thank you for giving that talk.
Thanks for coming.
You talked about in the beginning of the talk. You talked about like sort of the social costs of businesses now implementing security, but none of your theoretical models include human cost in them, and this is a little concerning to me because you're sort of playing the business's game. You're sort of saying, "Oh well, this is bad, right?" You had that diagram with the whole demand stuff, and like, "Oh well, demand will go up for this company, or demand will go down for everybody." But we live in like a smartphone world where more and more businesses expect their employees to have smartphones. So, yeah, Android may have vulnerabilities, but
But you can't choose not to use it.
yeah, everyone has to have a smartphone. So how do we include, how do we resolve this dilemma? How do we include more human metrics into these theoretical models?
Thank you for that. You are absolutely right. My models are sort of, I think of them as coming from sort of that economic, fully rational, if I want to talk to business leaders, talk in their language approach. And there's a piece of me that feels completely like I'm missing the point. I feel empty about using these methods because I am missing the social costs. And that's where some of the movement of the new work is, to try and understand that a little bit better. I do have some work that sort of tries to, but again, it's modeling it in purely economic terms. Tries to look at what is known as sort of social welfare. So what do we get out of using these tools that is both plus and minus, and trying to find that balance. That's the type of work that would help inform the policymakers to say, listen, here's what you can do and what you can't do. Do we need to regulate businesses from using these employee ID cards that can listen to me and track everywhere I go? Now, personally, yeah,
Yes.
Absolutely. Personally, I absolutely believe that. But I've had, and I have some students who are now looking into things like, I have a fitness tracker. A lot of us have fitness trackers. There are companies who will give fitness trackers to their employees. Now that can, in the US, you'd say, well, this is maybe helps you with your health insurance plan and other things. Yeah, the rest of us in the US are like, ugh, right? But there are cases in other cultures and other jurisdictions where it's actually kind of helpful, because if you are in a culture where work is such a big deal that you work yourself to death, so knowing that your stress level has hit a certain level and having someone send you home because you're never going to go home on your own because that's not the culture, maybe it's a good thing. I don't want to, from our culture, it's a horrible bad thing. But we have to sort of play with these, and I don't know the answer, and I do still want to be, like, that's kind of where I'm trying to take my research, is to really look more at the human aspect and how this is affecting us and how we can make these choices. Not just, like, I can't make a choice about who I work for. I mean, many of us don't have that luxury yet. And so if you need this job and you must do this, are there workplace protections that can be put in to safeguard you? I think some jurisdictions do better jobs than others, and we have a lot of work to do. And that is definitely, for me personally, a failing, I feel, in my work, yes.
Is it okay if I ask a follow-up question?
We have time for this one more, maybe.
We can talk offline too. Yes, sir.
Hi. Thank you for a very, very cogent and understandable presentation of some of the issues and risks. I have several security letters after my name, which I spent months and thousands of dollars acquiring, so that's my qualification, really. But I'd like to address one thing that hasn't come up, and it might be relevant to what you're doing. It has to do with the actual development process itself. I recall taking in my company a week-long class in project management, which was then to result in certification of people who were qualified then to run projects, keep them on track, make sure that all of the various risk-based elements were included. And at the end of the course, I talked to the instructor. I said, and nowhere during the week did we talk about security risk. And you understand that if we get to the end of the project and no one has achieved the security certification necessary to put it into production, or if the legal department decides that there might be a legal liability, the project will be delayed, and that, in fact, is a project risk, and it's not included. And almost everything you've talked about that's developed is part of a project that's managed by someone. So I'm wondering if you see that as an area that might be addressed.
It's an area that needs to be addressed. and I mean, there has been work on creating, like, as I talked about, the systems development lifecycle, the security development lifecycle, trying to mesh them in. But to the extent that it's not making its way into the risk management considerations of project management is distressing. But that, I guess, that is a little bit about what pushed me to start doing what I, to go back and think about business and where the business decisions are making. It's actually saddens me that we are still so far away from accomplishing that task. So I'll take that back in my teaching, but I'm not sure that I can largely address it yet. Thank you.
Thank you so much for coming.
Thank you.